So in this exercise, we're given a network mesh, and we're given some of the current flow between some of the nodes, but then there are some that are unknown. Actually, there's 5 unknowns. There's IX, IY, IZ, IU, and IW. And so they're asking us to use nodal analysis to determine what these unknown currents are. So let's look and see how we're going to do that. So the first node we want to look at will be node 2. And so remember, we have to conserve energy, which means we have to conserve current, which means that we have to account for all current. It can't be destroyed or it can't disappear or anything like that. So if we do that, we see that there are 3 branches coming in and out of this node. And so we're going to define current leaving the node as positive, and so if we add all those up, they should equal to 0. So we can see in this branch here, we've got 1.2. In this branch here, leaving, we've got 2.6, and then here we've got I sub x, and this should all equal to 0. And so when we solve this for I sub x, we just subtract 1.2 and 2.6 from each side. And when we do that, we come up with Ix is equal to negative 3.8 amps. And so what that means is, even though we show the current here leaving the node, the negative sign means that it's actually going into the node. So it's a negative 3.8 amps. So that is our first current that we found, Ix. So now we want to look at node 3. So when we look at node 3, let's see what we can figure out. So again, in node 3, we've got current coming in here, we've got current coming in here, and we got current leaving here. So there's 3 paths. And again, if we add all those up, then they should equal to 0. So again, we're going to say leaving the node is positive. So we have 3.5 amps going into the node, so that'll be a negative. So that's negative 3.5. And again, the negative is just because of the direction. If it was leaving the node, it would be positive, but it's going into the node, so it's negative. Then here we've got I sub u, so that'll be plus I sub u. And then here we've got I sub x. Now, remember, we said that leaving the node is positive, going in is negative, but the value of Ix is negative, so it's really double negative. So when we do that, it's going to actually be plus 3.8 amps. And so when we add all those up, those again have to equal to 0. So when we add those up, we just add 3.5 to both sides and subtract 3.8 from each side. And when we do that, we will get a negative 0.3 amps. So there's our second unknown current that we have solved for. So now let's move on. Let's pick another node that we think that we should be able to solve. And when we do that, we're going to take a look at node 4 now. Oh, sorry. Node 4, which is right here. And so we'll do that here. And so when we look at node 4, we see again we have 3 paths. And again, we'll just say arbitrarily, we could say one way or the other, it doesn't really matter. We'll say leaving is positive and coming in is negative. So the first one we see is this one here. We have 0.9 amps leaving, so we said leaving is positive, so it'd be 0.9. And then we said we have coming in this way into it is negative, but that value IU we just solved for has a negative value, so then that'll be plus 0.3. can be a little neater with that. 0.3. And then finally, we've got our unknown, this IY, which we're assuming is coming into the node. So that would be a negative I sub y. So now that should all equal to 0 if we add those up. So now we solve for IY, and when we do, we subtract 0.9 and 0.3 from both sides, and then we reverse the sign because we have a negative IY, and when we do that, we see that IY is then equal to 1.2 amps. So there's our third unknown. All right, so we're getting close now. So now we need to pick another node. And this time we're going to pick node 1. So let's see what happens when we look at node 1. So when we look at node 1, again, we're going to say leaving is positive. So if we look on this branch here, there's 3 branches going in and out of this node. We have 1.2, but it's going into the node. Well, we said that was defined as negative, so we'll say negative 1.2. And then we have our IY, which we just solved for, and we just say it's leaving, and that's correct, so we'll say 1.2 on that one. And then we have this last leg where we have an unknown IZ, and it looks like it's assumed to be going into the node, so we will make that a negative because that's the opposite of the direction that we said was positive, which was leaving. And when we add all those up, they must equal to 0. So here, when we solve for IZ, we see that the negative 1.2 and the positive 1.2 cancel out. So oddly enough, IZ is equal to 0. So no current flows in that in that from node 1 to 6. And so that leaves us with one last unknown to solve for. And so for that one, we're going to look at, we're going to look at node 6. So that'll be right here. And for that one, just use black. And so here, again, leaving is positive. So here's the first leg. Here, let me clean this up so it won't be confusing. So the first leg coming out of this node, again, we said leaving the node is positive. So that'll be 3.5. And then here we have this I sub z leaving the node. But we calculated IZ as 0, so we'll just say plus 0. And finally, we've got this IW, which we're assuming is going into the node, which is in the negative direction. So we'll say IW, and we add those up, and they must equal to 0. And so when we solve for IW, we see that IW must equal to 3.5 amps. So there's our 5 unknowns, and you can see how we got each one by the color code of the nodes there.